Hello guys, today see in this one problem 3 hinge arches in this video. First one is see the problem 3 hinge arches, 3 hinge parabolic arch of a span 33 meters and rise 7 meters. See here 33 meters distance between two supports, span is 33 meters here and 7 meters rise here, 7 meters rise of arch and UDL 45 kilonewtons per meters. UDL is 45 kilonewtons per meters all the span enter the length and 250 kilonewtons at a distance 7 meters from right end here, right end to 7 meters distance 250 kilonewtons point load is acting. Next one is the find the horizontal thrust and bending moment and normal thrust radial shear at the section 5 meters from left support. From here left support at a distance section 5 meters. 5 meters distance. See here one by one. The arch is considered here. Before solving the problem, the moment will take clockwise is plus positive and anti-clockwise is negative. We assume the sign convention. See here moment applied at B. Here applied moment at B here and moment equal to load into perpendicular distance. Here load VA into distance is 33 meters. VA 33. Next one is the UDL. This is acting is VA is clockwise. UA is clockwise. So we take is a positive. UDL here 45 kilonewtons entire length. UDL is converted into point load 45 multiplied with the distance 33. Next one is the half of the distance, perpendicular distance 33 by 2. This is anti-clockwise. This is acting anti-clockwise. Taking is minus sign. Next one is the 250 kilonewtons acting at a distance of 7 meters. It is anti-clockwise. It is taken as a negative. And we get to solve this VA equal to 795.53 kilonewtons. Next one is and find VB. How to find VB? Sum of the vertical forces equal to 0. Here VA vertical force acting VA plus VB upward is positive. Upward is positive, downward is negative. Writing here upward is positive, downward is negative, and right side is positive, left side is negative. Sign convention. And VA is upward is positive and VB is upward is positive. Taken UDL is load into point, convert into UDL into point load 45 into 33 into point load. Here 45 into 33 point load. Here up it is acting in downwards UDL, taking as a negative sign. Next one is a minus, because of it is a 250 kilonewtons acting is downward, 250 kilonewtons is adding downwards is minus sign, equal to 0. And we got a VA. Substituting here VA, replace 295.53 minus and 45 into 33 we get to 1485 minus 250 equal to 0 and adding 1485 minus 250 again 1735 and plus 79.53 minus 1735 we get 93.947 VB value. See here we got here. We find the reactions. First step is the reactions finding. VA and VB find out. Next one is the find the horizontal thrust. Find the horizontal thrust. How to find horizontal thrust? The moment applied at movement applied at crust. Movement applied at crust. That means MC equal to 0. See here point movement is applied, and VA we got a, VB we got reaction, support reaction, VA into distance movement, VA up is clockwise into distance 16.5, here multiplying 16.5, and horizontal reaction here, horizontal reaction into distance is 7 meters, and it is anti-clockwise, take as a negative sign, and 45 kilonewtons here UDL acting this span 45 into distance is 16.5, here 16.5 is converted into UDL, this span into 16 point half of the distance, here to here distance, half of the distance, 16 by 2 equal to 0. It is acting as a, this load is acting as a anti-clockwise, taking as a minus sign, and solve this to find the horizontal thrust equal to 1000.1 kilonewtons horizontal thrust. And next one is the bending moment at 5 meters from left to support, taking a section from left to support, left end to 5 meters one section, and applying moment, before moment applying, find the height of the this depth height, finding this formula we know 4hx L minus x by L square, 4 into h is the height, rise of the height of the arch 7, into x is the distance 5 meters, and L is the length of the arch, we gain 33 meters, and x is the x is the at a section 5 meters, here given in the given question 5 meters by L square 33 square, can get the 36 meter, here writing 36.6 meter, 6 meter, and applying movement at section, load into distance, this is clockwise load, VA is clockwise into distance is 5 meters, and next one is the horizontal reaction is anti-clockwise, minus into distance is 36.3 meters, load is acting is anti-clockwise, is negative, it is anti-clockwise, and 45 kilonewton UDL is converted into point load, 45 kilonewtons in distance 5 meters, and into 5 by 2, you can get 2.5, and solving movement in at D equal to minus 185.21 kilonewtons. Next one is the found the angle equal to formula theta equal to slope angle tan inverse 4h L square into L minus 2x whole into tan inverse, here 4 into h is the height of the arch is 7 meters, and L square is the length of the arch is 33, and L is the length of the arch 33, 2 into x is the distance from section to left to support is 5 meters, and substituting theta equal to 30.598, and normal crust formula here, normal crust formula n of x equal v of x sin theta plus h cos theta. How to find v of x equal to here v of x equal to here find out v of x here, this VA is acting upward, VA some of the vertical force is taking, VA equal to 79.53, and Here UDL is converted into point load. 45 into 5 is point load converted. Here we will get the 570.53 kilonewtons Vx value. Substitute here Vx value and sin theta equal to 30.598 and plus H equal to, we got in H above moment applied and H equal to here 1000.1. Substitute here cos 30.59 and we get the normal thrust value. And similarly radial shear equal to, just substituting Vx value and cos theta minus H sin theta, we get radial shear. Thanks for watching.